We're going to be taking a look at example 2 of u substitution combined with the definite integral. We have the definite integral from 0 to pi over 4 of tangent of x times secant squared of x dx. How do you know it's u substitution? Well, if you just try to take the antiderivative of this big thing, it's not going to work out, right? You can't just take the antiderivative. You're going to be required to use u substitution, and you're going to be combining this with the definite integral. Again, the key here, as we looked at in the last example, is once you figure out what u is, these limits have to change, okay? In terms of u. Right now, they're in terms of x. Eventually, they will have to be converted to u. And to me, that's like the fundamental step in u substitution combined with the definite integral. All right, so let's take a look. All right, so we are actually going to work this problem out together. Again, step 1 is to always figure out what your u is. Now remember, when you figure out u, you want your derivative to look like something that's already in the equation. Okay, so this one to me is pretty obvious. If you know your trig derivative as well, you know that the derivative of tangent is secant squared. And right off the bat, you can see, well, if I make u equal to tangent, my derivative secant squared already occurs in the equation. Hopefully those will cancel, right? That's what we want. So therefore, for step 1, we're going to make our u equal to tangent of x. Very simple. All right, step 2 is to take the derivative of that equation with respect to x. So basically, it's going to be d dx of u equals tangent of x. So we're kind of taking d dx of both sides. Over here on the left, we get du dx. On the right, we get secant squared. All right, step 3 is to get dx by itself. And as far as I know, you always end up cross multiplying here. So it's going to be du times 1 equals dx secant squared x. Or du times 1 is just du. You get du equals dx times secant squared x. Okay? Now, how do we get dx by itself from there? We just divide both sides by secant squared. Okay, so we get du over secant squared x equals dx. Okay, step 4. All right, now we're going to replace the expression by u and dx in terms of du. Now let's just go ahead and rewrite our question here. We're going from 0 to pi over 4 of tangent secant squared. Okay, so here's what the substitution looks like. We said u was tangent of x. We got dx by itself. It was equal to du over secant squared x. So when we replace these, it looks like this. And like I said before, we can see now that this is going to cancel out. In fact, I'm going to go ahead and just put the slash through it because it's going to go away. And let's read step 5 together. It's going to be to simplify. So that will go away. And I'm just going to use blue here. The limits, again, right now are in terms of x. They have to be converted to u. But for now, we're just going to write u du since the secant squared canceled. All right. Step 6 is to basically make sure there are no x's left in the equation, which there aren't, except for the limits, of course. We will have to change those. If there are any x's, you have to get rid of them by using the original u equation to cancel it out, which we've seen before and with u substitution. Same thing for step 7. You would replace any remaining x's in terms of u. All right, but step 8, can it be integrated? Well, I'm going to go ahead and check it off and say yes, because it's just u du. We can integrate that using the reverse power rule. Step 9, my favorite step, we need to convert the limits of integration by plugging them into the u formula. I like to think of it as a fish. All right, so here are our original limits, 0 to pi over 4 in terms of x. Now we want to arrive at our new limits in terms of u, whatever they may be. What I like to do is just draw my two separate integrals. In the middle, I'm going to draw my original u equation. U equals tangent of x. And then what I like to do is right above that, just go ahead and plug in each of these limits. Okay, so the first limit I'm plugging in for x is pi over 4. That is my upper limit. And if you remember from trig, tangent of pi over 4 is actually just equal to 1, which is awesome. All right, that was a terrible one. Let's try that again. It's much easier than our original limit. Okay, and then on the bottom, let's use a different color here. Let's see, that will be fine. Okay. We will be plugging in x on the bottom. Sorry, 0 for x on the bottom. And tangent of 0, see, tangent is y over x, so it's going to be 0. Because tangent of 0 degrees, or 0 pi, however you want to think about it, is just y over x. The y value is 0, so it'd be 0 over 1. 0. All right, so that's kind of our new fish. And I'll go ahead and just, put what we're integrating. We're integrating u du. And look how easy it is, from 0 to 1. This is going to be incredibly easy. All right. So let's go ahead and do that. So step 10 is to take the antiderivative. So antiderivative of u is, well, if you think about the power is 1, so it'd be u squared over 2, right? From 0 to 1. Again, you don't need a plus c because it's the definite integral, you're just plugging in your limits. All right. Step 11, plug in the upper limit and evaluate. So you're going to be plugging in that 1 into u squared over 2. That's 1/2. That's what happens when you plug in the upper limit. When you plug in the lower limit, it's going to be 0 squared over 2, which is 0. And then for step 12, subtract the evaluation of the upper limit minus the lower limit. Well, the upper minus the lower would just be 1/2 minus 0 equals 1. That's it. Basically, we found out that the integral, the definite integral from 0 to pi over 4 of this very complicated function is just 1/2. Let's take a look at the graph and see what that looks like. All right, here's our function, which is a tangent of x times secant squared of x. And it's pretty crazy. As curvy as this is definitely a trig function. The integral, definite integral from 0 to pi over 4 of tangent 10x secant squared of x is just 1/2, or 0.5. All right, so that's it. Again, the key to this lesson is making sure you switch those limits after you do u substitution and then integrate, and it becomes very easy from there. If you have any other questions about this example, let me know.